Okay, for question 16, you need to use V equals to IR correctly. But first, let's identify whether this is a series or a parallel or a composite circuit. So since all the resistor is on the same wire, you know that this is series circuit, and in series circuit, the EMF is shared by the resistor. Okay, meaning that this 12 volt will be distributed to each of these resistor. So since you know the potential difference for the first resistor is 2 volt, you would know that these two resistor would have a potential difference of 10 V. Okay, and since you already know that the current flowing here is 2 ampere, meaning that the current here, the current here, the current here will be 2 ampere. So you can actually now apply the V equals to IR to the 3 ohm resistor, only to this 3 ohm resistor. Okay, so the current flowing through the 3 ohm resistor, of course, is 2 ampere since it is a series circuit, and the resistance of the 3 ohm resistor will of course be 3. So with that, you will find out that the potential difference of across the 3 ohm resistor is 6 volt. So you know that this guy is having 6 volt, so 2, 6 remaining here would be 2 volt, and that's how you, oh sorry, 12 minus 2 minus 6 is 4. So therefore you know your answer is A. Okay, for your question 17, you are asked to find the effective resistance. So you have to simplify bit by bit. So you see that this 5 ohm and this 5 ohm is in series, right? So combine them, become a 10. Okay, this 6 ohm and 4 ohm are in series, right? So combine it as a 10. Yeah, so that's why here I wrote the effective resistance of the upper wire will be 10 and the lower one will be 10 as well. So after that, if you imagine now these two combine into one, these two combine into one, and the result is that these two will be connected in parallel. So you have to use the parallel formula. So 1 over 10 plus 1 over 10. So remember here, you have to flip it, okay, because down here this side is actually 1 over R effective. So after you flip it, you'll be able to get C. Okay, this question 18 is basically your basic testing you on the basic concept of practical electricity. So the live wire will always be carrying the high potential, and your neutral wire will always get 0. Okay, because you want the current to flow back to the power plant, and your earth will always be 0 as well. So therefore you have option A. Okay, then for question 19, which one proves that a piece of metal is a magnet? And the only confirmation test for either a magnet or an electrical charge is that a repulsion reaction. Okay, attraction doesn't mean that the other guy is a magnet. For example, if I have a permanent magnet bar, I bring it close to a paperclip. A paperclip is not a magnet, right? But still they will attract. Yeah, so attraction basically doesn't tell us much meaningful information. Okay, so therefore your answer would be B. Okay. By the way, a compass needle is a magnet. Okay, a compass is basically a magnet. So when a compass needle get repelled by this metal, you would know that okay, there's a repulsion interaction, and hence this metal must be a magnet. So therefore you get option B. Okay, last question of the MCQ. Okay, down here, first you need to be able to identify which one is your positive and which one is your negative. Okay, so the current flows like that, and you can trace the wire and you can find the direction of the coil. So you want to know what is the magnetic field that is produced by this current in the coil. So what you do, you have to use your right hand rule. So this index fingers corresponds to the current flowing in the coil. So imagine now you have a rod here. I'm going to demonstrate to you how I use my right hand rule and apply it to the left car. So this is the rod on my left car. My fingers are in front of the rod, right? And since the current is going down, it will go like that. So therefore my thumb is to the right hand side. So therefore you know that, oh okay, the magnetic field generated by the current in the coil is like that. Okay, you do the same thing here on the car on the right. So this is my rod. You can see that now the current is going up. Okay, so put your finger, wrap around the rod going up, and you see now the thumb is on the left. So you know that, oh okay, this is the magnetic pulse that is being generated. So like pole will repel and hence it will move away from each other. Option B.